Hello and welcome to SPSS Part 4, starting from S12. Here we're onto correlations. So to make a scatter chart of visitor numbers against holiday price. So this is stuff you've done before. And really this correlation test is really no big leap, as you'll see, because you've pretty much done it already. So go for correlate by variance. The big challenge is remembering which variables you're looking at for 2 seconds. So holiday price and visitors. I've lost the dialog box. There it is. So holiday price and the visitors go in there. Press OK, and it all just happens. This results we're getting. So correlation coefficient is negative 0.268, and the negative means that in this sample, the higher the holiday price, the fewer the visitors. And the fewer the visitors, the more the holiday price. Fine. So create the scatter charts. You can use the to make the scatter charts. You can use. Let's start from SPSS data. You can use the graph builder, chart builder. Initially, so chart builder pops up like that. Scatter chart. Just drag a basic scatter chart to here, and say you want the holiday price along here. And number of visitors along here. Just drag it on. You should get. So you've got this kind of scatter chart, which hopefully matches the one that we've got there. Yeah. So it looks like there's some sort of loose downward trend, not very strong, but there aren't many very expensive holidays with lots of visitors. So there's a general downward trend. There are a few cheap holidays with a few visitors, but most of the cheap holidays have got more visitors, so it's a negative relationship, which is why it's negative 0.268. Question is, why do we still need to do a test? And I promise it is the last time, almost probably. And the reason we have to do a test is that this correlation coefficient, negative 2.68, and the scatter graph here only apply to the 60 firms in our sample. We want to know, does this correlation also apply beyond the sample in the whole population of 880, or the whole population of firms in the world, or wherever we've got this from. So that's what the test will us to do. So null hypothesis is this: holiday price is not correlated with the number of visitors. Alternative is holiday price is correlated with the number of visitors. Logic is exactly the same. We start by assuming H0 is true. So if H0 is true, then we want to know what's the chance of getting a correlation as strong as the one we got, just randomly, if there's really no correlation in the population. So the answer is sitting there in front of us this time, because every time you do correlation in SPSS, unless you ask it not to, if you just say, give me a correlation like we did, it gives you the value of the sig value from the test, which is this 0.039. So it's dead easy. 0.039 is 3.9%. It's pretty small. So the answer to the question is very unlikely. If there's no correlation in the whole population, chance of getting a sample of 60 with a correlation as strong as the one we did is 3.9%, which is pretty small. So there's something wrong with the null hypothesis. It makes us doubt that. So we want to reject the null hypothesis at the 5% significant level, because 3.9 is less than 5. So reject H0 at the 5% significant level, adopt H1 instead, and the final conclusion is that there is fairly strong evidence that firms that have got lower prices have more visitors. Okay, I think because correlation is so simple, we can look at some other possibilities now. What other pairs of variables do you think might be correlated? So you can just look at the variables. If we can get back to the thing which has got variables in it. So you can look at these variables. Which of these might be correlated? Well, really, you can make a case that any of them being correlated, like visitor numbers, is that going to be associated with energy per person used, or water per person, nutrition levels and income? So what you could do is think perhaps that would energy level and water level be linked? Perhaps visitors and energy, because visitors and energy, you think that a larger scale thing might have some economy of scale, or it might mean that it's more luxurious, or no, perhaps less luxurious. So Could be a combination between holiday price and so between visitors and energy. So let's just check that by doing a graph. So holiday price, I need to get rid of that. And that's, I think visitors you want to go on the x-axis. And then energy, natural on that axis. Yes, it looks as though possibly more visitors using more energy per person. Possibly. Because the larger scale ones are using air transport or something to get people around. Who knows? Let's do the test to see if that, although if we get the correlation coefficient, that needs to do the test. Because that's got the test included, so correlation bivariates. So I'll keep visitors and I'll put in energy. There it is. Oh, yes, look at that. Very significant. So this correlation coefficient is 0.369. And if the null hypothesis is true, so if in the whole population of firms there's no correlation, the chance of selecting 60 with as strong a correlation as that is given as 0.004, which is really small. So that null hypothesis is not very compatible with the data. I want to reject that. I reject it at the 1% significance level because this is less than 0.01. So there's very strong evidence here there is a connection between the number of visitors and the amount of energy per person they're using. If you want to, what you should do really is to think logically, as we did there, about what's likely to be connected, theoretically, and then test it. If you're more lazy, you can just do a kind of data mining thing, but that does throw up problems. We can just do the bivariate correlations and really just throw in every numerical variable. So I'll just put them all in, and then just sling out the ones which are categories. The ownership type is a category which doesn't really have an order. Equal license is a category and manages a license. Everything else you can think has got some sort of order to it, so you can test if there's correlations between these things. If you do that, you get a big matrix like this. And all you need to do is to look for the small. Oh, I'll tell you what I didn't do. What you need to, that's a small probability, so that probably is significant. Look for these small sig values, so views, nutrition is likely to be correlated. To make life easy for yourself, it's worth ticking this box here. It means it puts stars next to the ones that could be correlated. So this one here, biological impact, number of visitors and the bio impact, 0.572. So quite a strong positive correlation. Not surprising that the more visitors, the more impact they're going to have. Let's assume that in the population, though, there's no connection. And what's the chance of getting that randomly just through luck of sampling? And the answer is 0.00, so it's really, really low one. So you can definitely reject that null hypothesis. There's really strong evidence here that number of visitors is connected with biological impact. Some others with stars, there's one here, star here, income, PC, nutrition. Okay, that makes sense. Yeah, so income per capita in the area where the firms operate is very highly correlated, 90% correlated with nutrition of people, because clearly if they've got some income, the number one priority, they can feed themselves. So yeah, that's highly significant. If in actual fact there's no connection in the population between income and nutrition, chance of getting a value as high as that is again 0.000. So you can reject that null hypothesis. Very strong evidence of that connection there. Let's do maybe one more. It's interesting. That's one we looked at already. That's one we looked at already. Nutrition, that's not very exciting. Off-season holiday price. Holiday price and income per capita. All the ones with stars, you can see, it's just a matter of whether you can explain them. So nutrition, that's an interesting one. So this is the connection between nutrition and bio impact. So it seems that in areas where there's more nutrition, then there's a lower biological impact. And biological impact, I can't remember if that's a good thing or a bad thing. Bio impact, high damage. Okay, yeah. That's interesting. So yeah, so I suppose that means that in areas where there's more bio impact, nutrition is lower. So there's obviously the eco-services that people could depend on are being hit. So there's lower nutrition. And on the other hand, lower environmental impact means better nutrition. Yeah. So there's a negative correlation, 0.475. If it's just if there's no real connection in the whole population, the chance of getting this in our sample is 0.000, very, very low. So we can reject that null hypothesis and say accept the alternative, which is there is a correlation between impact, biological impact, and biological impact and nutrition levels. Okay, so there's a couple of examples there. You can explore others yourselves. So and this correlation matrix, as it's called, makes it very easy to do that. Okay, I think in the next part we go on to looking at comparing categories. But for now, thank you for watching.